In problem C4, we have a water skier pulling on a rope. And this one, again, people have a hard time drawing. I think it's really easy to do if you look at it from the top. So here's our boat. We're a little bird floating over the top of the boat. And here we've got the little wake of water coming out from the boat. And directly behind the boat, we have our little water skier. That's the top of his head. Those are the skis. We're looking straight down from the top. So when our boat is crashing through the water like this, he's going to feel a force of 249 newtons when he's directly behind the boat. Well, what's the tension in the rope when the skier cuts out 39.5 degrees? So if he cruises out over here, so now he's skiing over here, so that this angle becomes 39.5 degrees. We want to know how strong is the tension in the rope now. Well, clearly I can just make this into a nice little right triangle, and what I'm looking for is the hypotenuse. So if I'm looking for the hypotenuse, I have to say, well, compared to this angle, this side looks like it's adjacent. If I have adjacent hypotenuse, I have to use cosine. So here I'm going to say the cosine of my angle, 39.5, is equal to the adjacent side, which was 249 over my hypotenuse, which I don't know. So again, if my unknown's at the bottom, those two will just trade places. And I'm going to say x is 249 divided by cosine 39.5. So if I plug that in correctly, I end up with 323 newtons. And so he's pulling quite a bit harder here than he was when he's straight behind it. Which means if you have a cheap rope, you might be okay when you're back here, but when you cut out over here, your rope's going to snap on you.